as we said, I'm Jonathan Eaves. I'm a technical marketing engineer working in the ISE team at Cisco. So I'm going to talk about some more advanced features on group-based segmentation. And as an introduction, I'm just going to talk about what I presented in the previous session. So this was the group-based segmentation basics. So this was presented on the 4th of August. And if you go to cs.co/ISE-webinars, you'll be able to watch this recording if you haven't already seen it. But it's sort of a prerequisite. So I did cover an introduction to the technology in this basic session and a description of what we call the 3 pillars for the technology. So that's classification, propagation, and enforcement. I'm going to go into more details in that. And what CTS provisioning and network device enrollment means. I mean, this is really required for enforcement because you don't need that if you're just going to be classifying and propagating. But this is where you download a protected access credential and download the environment data for use in enforcement. I'm going to go into more details on that today. And then I covered a couple of use cases. So a single platform, if you've got 2 endpoints on a single platform, and you're sending data from one endpoint to another, then you can enforce, and I showed that use case. The next one is multiple platforms. Of course, if you've got endpoints on different platforms, then you need to propagate normally the source SGT from the source to destination. So that includes propagation. So we talked about that previously. And we covered some best practices, and then an introduction to a couple of security policy access or SPA apps on Cisco DNA Center, being endpoint analytics and group-based policy analytics. So that's what we covered before. So as an agenda then, in this session, we're going to go into more details of classification. So different methods of classification, what the unknown SGT is and what we use it for, order of precedence, because you could have multiple mappings for the same IP address to different groups. So I'll talk about order of precedence. The network device SGT, the server list, and the default route SGT. We're going to be covering them today. In propagation, we're going to be covering how ISE sends mappings to the network using SSH and SXP. We're going to cover SXP Domains, and then move on to the network device itself. So how to monitor propagation, typically inline tagging on network devices. Going to talk about SXP Reflection, SXP Filters, and a new version of SXP called SXP version 5 that came in 17.9.1. And then moving on to enforcement, monitor mode, logging, and counters. And then I'll just finish off with a new doc that we've written for SGT support on the 9800 wireless LAN controller. Okay, so moving on to classification. Classification methods. So what do we mean by classification? Classification just means we're assigning a group to a learnt IP address of an endpoint or a user. That's what classification is. And we can do this from Identity Services Engine. So this is dynamically assigning an SGT to an IP address of a user or an endpoint. So you see on the left there, we've got mab.1x or WebAuth. And as these endpoints connect to the network, we can use these access methods to send a radius request to ISE, and then part of that is authorizing those endpoints using an SGT. So this is classifying, actually it classifies the learnt IP address of those to a group. Now we also use passive ID. This is a method by which we can use MAB, so an endpoint that does not have a .1x supplicant, so it connects with MAB. But then we can glean the user ID directly from AD. Once the user's logged in to AD, we can scrape that off of AD, and then we know that it's a secure. We can give full access to that user once we know that it's an employee, and then we can reauth that endpoint and give full access privileges to that user. So we can use passive ID as well. So these are all access methods that we can dynamically assign an SGT to those users or endpoints. So that's dynamic classification. Alternatively, there may be some endpoints that are not authenticating with ISE, and typically we will classify these statically. So there are a number of different methods. The first one on the bottom left there is statically classifying an IP address to an SGT. And there may be several different IP addresses around the network that you're classifying into the same role. Maybe they're all employees. Normally you would dynamically assign an SGT for employees. Maybe these are all just server types, so marketing server types. And you want to put all these into a group and assign the same SGT. So you take the IP address and you statically classify those IP addresses into a group. This is IP to SGT mapping. If all the devices on a subnet are going to be assigned into a group, then you can do a subnet to SGT classification. That's another way of doing it. At the top there's a VLAN to SGT classification. This is another static method. And what this actually does is that it learns the IP addresses on this VLAN. So we need device tracking, IP device tracking. And the IP addresses we see on the VLAN, we assign to this statically assigned SGT. Another method down the bottom there is port to SGT classification. This just means any traffic coming into this port, I will assign to this particular SGT. And this is normally done, when we connect hosts and things, and we don't want to be sending SGTs out to hosts. So normally, as you see down the bottom right there, we'll say no propagate SGT. So we do not send the SGT to the host. We just receive IP from the host and use that statically assigned SGT for internal processing. And the last one on the top right is a layer 3 interface statically assigned to an SGT. This actually means learn the IP prefixes from this layer 3 interface and statically assign them to an SGT. So these are static classification methods. And so we have two classification methods. One is dynamic, where ISE is assigning the SGT, and then we have static, normally for endpoints that are not authenticating with ISE. Now, I said that CTS provisioning and network device enrollment is really used for enforcement, which is true. You can, classify endpoints and you can propagate mappings without going through full CTS provisioning and network device enrollment. But you may want to do this is in the classification section, because you may want to do this to assign an SGT to the network device itself. Now, if you didn't go through the full enrollment, then you can still assign an SGT to the network device itself by doing a CTS SGT 10, for example. So you can do it through CLI. But if you're going to go through the full provisioning, what that means is we download a protected access credential from ISE down to the network device. A pack is used for EAP-FAST for the TrustSec communications between the device and ISE. And then we download the environment data. So what is the environment data? Well, it's basically a complete list of all the SGTs that are in ISE. And we have this local network device SGT. Now, out of the box now, we assign an SGT called TrustSec devices, which is SGT2. And this can be set, as you see at the bottom, under TrustSec policy and network device authorization. And as I said, this by default assigns SGT2. It doesn't have to be. Through that device authorization, you can change that. Or you can actually assign different SGTs for different parts of the network if you want to, if there's any reason. So under that network device authorization, you can configure a number of rules to assign what SGT you like to your devices. Typically, though, customers assign all the network devices to SGT2. And you might think, well, what is this used for? Well, it's for traffic that originates from this network device itself outbound. So it might be SNMP traps that are being sent. If you're on the box, if you're telnetting outbound, or protocols that are originating from this box, we assign to SGT2. The other things that are in the environment data is the CTS server list. Now, this is a list of servers that we want to update the environment data from and also download policy from. So this is a list of ISE personas, which can be the PAN or can be the policy services nodes. And some customers have a dedicated policy services node just for this policy download function. But that configuration is controlled as you see in the bottom right there under TrustSec components, TrustSec servers, and TrustSec AAA servers. Now, the first entry in this table is always used by all the devices to download policy. If that ISE persona is not available or not contactable for any reason, then it will move to the second instance. So that's how it works. So this is CTS provisioning and network device enrollment. As I said, only really used for, it's only needed for enforcing on this platform, but you can use it to define this TrustSec devices, SGT2, to the device itself. If you didn't want to go through full enrollment, then you could just use the CTS SGT and assign it via CLI. The final part of environment data are timers. So by default, a lot of the timers are set to 1 day. So this is when the refresh comes in. If you don't push or deploy any changes from ISE, when the timers expire, it'll then go and refresh the tables like the policies and the environment data. So that's the timer. So this is the environment data and using the protected access credential. So I wanted to touch on the unknown SGT. So on the left here, we've got 3 endpoints and they're all assigned an SGT. So SGTX, SGTY, and the third one, the badging system, is assigned SGTZ. Now, traffic flowing from left to right here, because we're inline tagging in the middle between switch 1 and switch 2, the packets flowing from left to right will carry the source SGT in the packet. In fact, it's in the layer 2 frame in the CMD field. That source SGT will be carried from switch 1 to switch 2 because we've configured inline tagging on this link. Switch 2 will take that SGT off the wire and we'll forward it to the right here. Again, it's inline tagging and forwarding onwards. So this is just inline tagging, forwarding the source SGT. Now, what happens if you have endpoints connected which do not have SGTs assigned? Well, switch 1 sees these and it sees there's no SGT, so the SGT is unknown. So what it does is it actually assigns an SGT which has a number of 0 and we call it unknown. So it's actually an SGT, it's called unknown and it has the value of 0. Now in this case, traffic flows from left to right and the 0 is in the tag, the CMD field, flowing in line. So what happens if on switch 2 we have static mappings or SXP mappings here? So we want to try and reclassify this traffic so that it isn't unknown anymore. Well, that does not work because 0 is trusted coming into switch 2. So we got inline tagging from these unknown devices. It's got SGT0 flowing across inline, hits switch 2, and because we've configured trusted here, 0 is actually trusted, and so it does inline tag 0 forward. Now I'm going to go into a bit more details on this in the next slide, but just remember that the unknown SGT0 is trusted as far as SGT inline tagging is concerned. So let's go into that in a little bit more detail. Again, we've got switch 1 on the left and switch 2 on the right. And we've got inline tagging enabled. So CTS manual, policy static SGT2 with a trusted option. So what do these commands do? Well, on the left, remember we've got traffic flowing from left to right. That's what we're going to be talking about today. When we do CTS manual, policy static SGT2 trusted, that is enabling inline tagging. It's enabling the use of the CMD field in the layer 2 frame. That's what it does. The policy static SGT2 trusted, SGT2 here does nothing for traffic on the left here, egressing switch 1. So nothing is affected egressing the box for this SGT2. On the right though, we've got switch 2, so we've got traffic coming into this box. We've got CTS manual, policy static SGT2 trusted on this interface. That enables inline tagging, so it enables switch 2 to receive the SGTs coming off the wire. If you've got the trusted keyword, then that means trust the SGT that I'm reading off the wire. Okay, so we're trusting that SGT. So if we've got SGT 10 on a user or an endpoint on switch 1, we've got SGT 10 flowing as a source SGT coming into switch 2. If it's trusted, it'll know it's SGT 10 and use that in its policy decisions. Now, if you don't have trusted, then it just means do not trust the SGT 10 that might be coming in. I'm going to reclassify the traffic coming in with SGT 2. And then also, if there's no CMD field at all coming into this interface, then also classify with SGT 2. So these last two methods are really like port to SGT classification. Any traffic coming in, I don't want to trust it. Even if it's got an SGT on it, I'm not going to trust it. I'm going to statically assign SGT2 instead. So this is what it means when we configure CTS manual with policy static. It's enabling inline tagging, and we're configuring whether we trust the SGT on the wire or we don't. And if we don't trust it, then we assign SGT2 inbound only. Outbound or egress, SGT2 does nothing. Okay, so that's what that command does. Now, we talked about order of precedence a little bit, but I'm just going to go through the order of precedence, because you may well have inline tagging where a platform and Cat9K in this instance is learning a group or an SGT off the wire from inline tagging for a particular IP address. Now, you could also have perhaps an endpoint connected to this 9K dynamically being assigned an SGT, and the learned IP address is the same one that's coming in via inline. That's a possibility. Maybe you have SXP sending the same IP with a different group. Maybe you've got port to SGT on here, again, learning the same IP. And you may have a VLAN to SGT learning the same IP. All very unusual, but it's possible. And we need to know which mapping and which group is assigned as an order of precedence. So inline tagging is the highest precedence coming into the Cat9K. Now, it's the same for the majority of our products. There's just one slight anomaly with the Cat4K. And if you want to know what the Cat4K does, you can read the troubleshooting guide there. That doesn't quite give the highest priority to inline, but most of our products do. So this is the highest precedence. If we've got an SGT off the wire, it'll use that for an IP address. Now, going down in precedence, the next is a dynamic assignment of SGT. So if the same IP is learned inline and also learned from an endpoint connected to the network dynamically, then it will prioritize the SGT it's assigned via inline tagging. Also going down in precedence, we've got SXP. And further down, we've got this layer 3 interface, learning the prefixes. Further down in priority, we've got static IP to SGT. So if you've got an IP to SGT for an IP address to a particular group, and you're learning through SXP, and you've learned the same IP, but to a different group, then it will prioritize the SXP mapping over the IP to SGT static classification, because it's of higher precedence. The next one lower is static subnet to SGT. And hopefully these two, it's clear to see that if you've got a large static subnet to SGT and you're assigning to a particular group, if you assign particular IPs within that subnet to a different group, then the IP to SGT takes precedence over the subnet. And then lastly in this circle is the VLAN to SGT. And this is typically the lower precedence. Remember, VLAN to SGT is learning the IP addresses in that VLAN and statically assigning an SGT to those learned IPs. And that's typically the lowest. So this is order of precedence. Hopefully that's useful, but bear in mind that if you've got inline tagging, then this will be the highest order of precedence. Now, if you've looked at the environment data download in detail, you will see that the environment data is split up into different blocks or different tables. Now, this was actually an enhancement made. I can't remember what release it was in, but previously, if you updated an SGT or if you added one on the end, it would have to refresh the whole table for any change. And if there's a large number of SGTs in the whole table, then that takes up resources and time. So this table was split up into blocks of 40. And you can see there are security group tables, 1, 2, 3, and so on. And there is a radius AV pair, which is called security group table, and it has a version number at the end. This is table 1 with version number 66, which means there have been a number of updates to table 1. And this is how ISE and the network device stays in sync. If there's a change, because ISE has, someone on ISE has updated an SGT, for example, then the version number will change on a particular table wherever it sits, and then the switch only needs to download that particular table or that particular block of SGTs rather than downloading the whole environment data list of SGTs. So that was just an explanation of not having to download the whole list. And I think that lastly, in the classification section, I'm going to talk about the default route SGT. So we've got a Cat9K here, and it's connected to the internet. So how can we classify all these different routes from the internet? And how can we enforce outbound if we wanted to, permit certain devices or users from accessing the internet or blocking that? How would you go about that? Well, one way is to classify all the different prefixes in the internet, right? Which you don't really want to be doing. But this solution works if you've got a default route on this Cat9K. So typically, and I say Cat9K, I mean typically you might have a router here, so it's the same if it's a router. But there must be a default route, and that default route can be dynamic or static. But you've got these simple commands to classify all the routes learnt from the default route. So we've got CTS role-based SGT map 0000/0, and we assign that to an SGT, and that works for IPv4 or IPv6. And we see them in the CTS role-based SGT map table. So this allows us to classify inbound any of these routes coming in via the default route. We will assign to this SGT, and it allows us to build a policy for outbound to permit or deny based on these mappings. So this is how we can use the default route and the default route SGT to classify or enforce. So that was the classification section. So now we're moving on to propagation. If you remember, propagation is about propagating the source SGT typically from one device to another. And the idea is that you propagate them towards an enforcement point, because at some point you want to enforce from source to destination. So I just wanted to talk about sending mappings from ISE. So we can propagate mappings from ISE down to network devices using SXP or SSH. Now I want to talk about SSH to begin with. So if we want to send static mappings from ISE to a network device, SSH needs to log on to that network device, so there needs to be some access credentials. And so in ISE, we've got our network device under network resources, network devices. Choose the device, scroll down, and this is where we can configure credentials for that network device. And this is what ISE will use when logging in to add mappings into that device. So if we want to add a mapping, then we go to TrustSec components, IP SGT static mapping, and we add a new mapping, and we add the IP to SGT, and then we choose a particular device. Now you can have groups of devices and that, but when you do this and you deploy this change, it will use SSH, log on to the device, and configure the mapping for you. So the other way that ISE can propagate this information is to use SXP. Now we can use the same table, so under TrustSec components, IP SGT static mapping. If we add a static mapping in here, then we add the IP to SGT, And this time we send it to the SXP table. In this example, it uses an SXP domain, which I'm going to talk about in the next slide. But we add it to the SXP table. And then if you've got SXP connections from ISE down to network devices, this mapping will be sent down through that connection towards those network devices. And as I said, this by default is using the domain, which is called a default. And let's talk about what that means on this slide for SXP domains. Now, out of the box, we have an SXP domain called domain default. Now, you can just use that. If all the mappings you receive or create on ISE, you just want to send all of them to all of your devices, then you just can use the default domain. It's really just a space in ISE, the same as you create a space for routes on a network device. You call that a VRF. But it's just a different space for mappings, so you can add different domains. So SXP domain A, for example, SXP domain B, for example. These are just if you need to send different mappings to different places. But by default, you have a default domain. If you add a static binding, WXYZ to SGT25, then there's one domain by default. It's called the default domain, and it goes into the default domain. If you have an SXP connection coming in, then on that connection, you tie that connection to a domain, and there is one by default. It's called the default domain. So any mappings learned through that SXP connection will go into the default domain. If you have dynamic mappings, endpoints authenticating with ISE, and assuming that you've enabled, so on the SXP settings, it says add radius mappings into the SXP table. Assuming you've got that selected, then the dynamic mappings assigned by ISE will also go into the default domain. So you've got all these mappings going into the default domain. And if you have an SXP connection tied to that default domain, and ISE being a speaker sending those mappings out towards this ASR, then all the mappings in the default domain will be sent out to this network device. So that's the default domain. And maybe that's the majority of use cases. You just have all the mappings in your default domain and you send them out through your SXP connections, which are terminated within the default domain. Now, just to complicate things, you don't have to use the default domain. You could have static mappings here. You can send mappings to multiple domains. So this ABCD is going into domain A and domain B, and this second mapping is just going into domain B. If you have an SXP connection that's a listener on ISE, you can terminate that in domain B if you want. You can also terminate it in domain A. So all the mappings coming in could go in both those domains. And you have an option for the dynamic mappings. So you may have seen in ISE, you have ISE SXP Filters. And you can use filters using the subnet or an SGT to say, based on a subnet or an SGT, if I see them, I want to put them in a certain domain. So you could say I want to put certain mappings in domain B or domain A for that reason, or into the default. So that's what the ingress SXP filters are for on ISE. And then if that's true, you've got these mappings in these different domains. Let's say you want to send some mappings out towards this firewall. As long as you have an SXP connection that's terminated within domains, this is an example where it's actually terminated in all three of these domains, then mappings in all three will be sent to the firewall. And this is just a simple example of an SXP connection purely terminated in domain B, and therefore only mappings in domain B will be sent to this device, down to this this device that we see here that's tied to that domain. So it's a bit of a complicated slide that we see right now, but hopefully the talk through simplified it. And this is an explanation of using SXP domains on ISE. Down on the network device then, we're talking about propagation. So if we're propagating from one device to another and it's inline tagging, then you can use the monitor capture command on the Cat9K as an example. You can configure the interface, you can match any, or you can choose what you match on. You can start and stop. And the first command I typically use when I'm doing this is a show monitor capture, and then the buffer. When you enter this command, it shows just single lines per packet with the protocols. So you can see if you're looking for ICMP, then you can see that maybe ICMP is in frame 52, and then you can use the buffer detailed beginning with frame 52, and then you can see the details of that frame. And this is an example of seeing the inline tag, the Cisco metadata in the layer 2 frame, and you can see if the SGT is within the frame. Now, I just wanted to make you clear that there's a little gotcha with this, and that is if you've got device 1 here on the left and device 2 on the right, and we're flowing traffic from left to right, you have to use monitor capture on device 2 here if we want to see what's on the wire. So the monitor capture here, you see the CMD being received from device 1. It captures what's on the wire. If you use it on the egress side, so traffic egressing device 1, then the SGT is actually inserted into the flow after the monitor capture is sampled. So if the monitor capture is slightly to the left of the SGT operation, so sometimes you'll see an SGT in the monitor capture when it isn't put on the wire, and sometimes you'll see nothing in the monitor capture when it really has been inserted by the SGT insertion mechanism. So just bear that in mind. If you really want to see what's on the wire with a monitor capture, you have to look at the receiving side. Okay. So let's talk about SXP and SXP Reflection. And we talked about SXP in the first basic session, but just to recap, it's really just a TCP connection from one device to another using port 64999. And it's just an overlay. I mean, we talk about overlays all the time, you know, CapWap, things like that. There are overlays. People, you know, sort of talk about them as being tunnels or what have you. But it's just a TCP connection from one device to another. And it can span many devices. You know, you can originate a TCP connection in Australia, terminate it in the UK, and it's one SXP hop, but it's going across many devices. So it's a TCP. It's a peer-to-peer connection rather than point-to-point. Okay, so you have a speaker and you have a listener. So an SXP connection goes from the speaker to listener, and it sends mappings from the speaker to the listener, IP to SGT mappings. Now, in this example, we've also got mappings coming down from ISE. So this platform in the middle here is really aggregating mappings. It's receiving mappings from a number of different places, and that's fine. It just adds them into the table and then can forward them out. It's assuming that this box here then is a speaker to the ASA being a listener, and also a speaker to this ISR being a listener. So this is what we call reflection. So we're receiving SXP mappings in, and we're like fanning them out and sending them out. And this is a typical use case of if you've got, you know, a very large network, maybe you've got mappings on ISE, you can send them down to a reflector and then send them out to a number of different devices because you need a lot of SXP connections. That's one example why you may need a reflector. So this is aggregation and also reflection. Bearing in mind, I'll use the ASA here because we're talking about native SXP using TCP port 64999. And the ASA supports this native SXP. If this was a next-gen firewall with a firepower management center and firepower threat defense, then the firepower management center downloads these mappings and from PXGrid, and it uses the SXP topic in PXGrid. So that's why I used the ASA as an example here. So this is SXP Reflection. Now let's talk about SXP High Availability. So we've got an endpoint on the left here. It's got an IP to SGT mapping, 1234 mapped to employees number 4. And then we've got a simple network diagram. And then what we're going to be looking at is the mappings on R5. So we've got an SXP connection from switch 1, if you like, to switch 3. and then another SXP connection over to R5. Now this is path 1 that R5 will learn this IP to SGT mapping via. So this IP to SGT mapping goes into the SXP table, and you can see the SXP table using show CTS SXP SGT map. And in the SXP table, there's a source. It's learnt about this mapping through path 1. There are 2 SXP hops, and it was learnt first. I mean, there's only one path that it's learnt so far, but it's learnt that first. Now, because there's only one entry, that is what's used in the role-based management table, the RBM table. This is what's used in the runtime. So the SXP table is a database of paths, and the RBM table is the runtime. This is what uses the best entry. So for 1, 2, 3, 4 mapped to SGT4, the best entry is the only one that's in the SXP table. There's only one. So it's from path 1. Now, we learn about the same mapping through another path, path 2. Now this has 2 SXP hops as well, but it was learned second, so we've just now learned about it. So in the RBM table, what is the best entry? Well, the hop count is the same, but it was learned second. So the best entry now is path 2 because it was learned second. So the first priority which we use in the RBM runtime table is the least number of hops, and the second criteria is learnt last. Okay. Now we learnt the same mapping from ISE. So what happens then? Well, another entry goes into the SXP table. There's only one hop, and it was learnt third in the list. But because there's only one hop, this is the best entry. So 1, 2, 3, 4 mapped to SGT4. The best entry is the one learned from ISE. So this is how it works. Now, as far as high availability goes, what if ISE is not contactable for any reason, and then the timers time out? Well, then the entry disappears from the SXP table, but the best entry now is still learnt. We still have it. We know that it's through path 2. And so the RBM is just updated with an entry which is already in the SXP table. So this is how we manage high availability. All the paths are known, so we can use the best one in RBM if we have to. And of course, the next example is maybe one of these goes down, but the one remaining path will still be available in the SXP table and can be used in runtime. So that's SXP High Availability. Introduction to SXP Filters. So SXP filters have been around for a little bit, but these can be very useful when you're designing your networks and sending mappings around the network. So this is an example of ISE sending mappings down to like a reflector, and a reflector sending them down to a couple of branches. Now this use case is the customer may want to enforce ingress enforcement on the branches. So if we're going to be ingress enforcing, the branches need to know the destination mappings. So on branch 1, we have dynamic mappings. So branch 1 and this router or switch will know about the dynamic mappings for the endpoints on branch 1. Branch 2 will know about the dynamic mappings in branch 2. But as far as SXP is concerned, why send branch 1 mappings back to itself if it already knows it? To enforce, we need to know the branch 1 mappings and the branch 2 mappings. So we can use SXP filters either on the speaker from the reflector or on the listener on the branch to add filter lists and filter groups so that the branch only receives mappings from branch 2. And equally, why send branch 2 mappings back to itself when it already knows them? You can use SXP filtering to only send branch 1 mappings to branch 2. So this is an example of filter list and filter groups. And we can quickly see here a quick example of ISE sending mappings down to the Cat9K reflector. On the reflector, you can enable the SXP filter. You can have a filter list to say permit SGT28 or permit IPv4 prefixes. So you can deny or permit SGTs as well as prefixes, IPv4 or IPv6. And there's an implicit deny. So it will only permit this one SGT and this one prefix. And then you have an SXP filter group, which really just assigns this filter list to this particular SXP peer, which happens to be ISE. So this is how you build your filters. This is an example of a filter group listener on the Cat9K filtering what's coming down from ISE. But you can configure them on the speaker and the filter, speaker and the listener side. Now I wanted to talk quickly about SXP version 5. Now, obviously the version means that there must have been 4 versions before. There was version 4, which supported IPv4, then version 2, IPv6, version 3 supported subnet to SGT, and version 4, which we've been using for the last few years, is loop detection and prevention and keep alive mechanism. So this is what we've been using before 17.9.1 came along. Now, what is the use case? Now, you don't use purely SXPv5 for SD access, but it's just a nice visual example. What is the use case? Well, the pain we need to go through with SD access is that generally you have certain number of virtual networks, meaning certain VRFs on the border. And if you want to send SXP mappings down towards these VRFs, you have to have one SXP connection per VRF. So if you had 10 VNs or VRFs in this fabric site, you would have to have 10 SXP connections, sending mappings down to those individual VRFs. Unreleased 17.9.1 has made this simpler. So this is an example of how this works. You've got a reflector here with 3 VRFs, and we want to send mappings down to a border. Now, the border only has 2 VRFs on it within this fabric, so building security and building management, and we want to send mappings down through SXP. Now, because both of these platforms running 17.9.1 supports SXP version 5, they will negotiate to the highest version, which in this case is SXP version 5, and it allows us to use some configuration which allows us to use an export list on the reflector and only send down mappings for building management and building security. Again, there's an explicit deny at the end of that list, so it will only send them. It won't send mappings from the default, and it won't send mappings from the IoT VRF. Then there's what we call an export-import group for the speaker side, which really just ties the export list to the peer. Now on the border side, we have what's called an SXP import list, and this says VRF. Now what this means is that traffic flowing within this SXP connection, it now doesn't only send the IP and the SGT mapping, it also sends the VRF. So what this VRF statement says is that take the IP and SGT and the VRF information from the packets flowing over and place the IP to SGT in the same VRF that I'm receiving it over. So the VRF is also now sent within this one SXP connection. And then we have an export-import group on the listener side, and we're just tying that import list to the peer, which is the Cat9K reflector in this case. So this is the real power of SXP version 5. You only need one SXP connection now, instead of the example previously is 10, for 10 different VRFs. And you can manipulate what mappings you send and what mappings you receive. So that's what SXPv5 is all about. And it is available today in the routers, the Cat9Ks, in the 9800 with release 17.9.1. So that takes me on to enforcement items. Monitor mode. What if we want to see how enforcement would work, but we don't want to actually carry out enforcement? We don't want to affect our users or endpoints. Well, instead of adding a policy as enabled, we can add the policy as monitor. Now I'm showing the screen from Cisco DNA Center. I mean, you can do exactly the same on ISE if you don't have Cisco DNA Center, so it's the same thing. What DNA Center does is just automate and orchestrate this configurations and pushes it into ISE. But there is such a thing as monitor mode. So what does this mean? Well, on the switch itself, if you look at the policies, the command is show CTS role-based permissions, then it shows that it's monitored. It's purely monitoring, but it has downloaded the exact policy that you want to download. It's just being monitored. Also, it shows hit counts. So the hit counts do show as under the monitor section, but it still shows the hit counts for you. And it also shows the syslog, which is generated should you have logging enabled on your security group access control entries. And again, you've got action monitor. So you can see all these mechanisms. You can see the policies downloaded, you can see the hit counts, and you can see the logging, but they're just monitor mode. Your end users will not be affected. Now, just to take logging a bit further, again on Cisco DNA Center, I'm showing the screen from there, but you can configure logging on ISE as well. But this is just showing an action, a content action, a contract action as logging on, and also the default action is logging off here. And this shows within the switch that you've got a log attribute on the back of your access control entry. And again, it shows through the syslog when you get a hit, it gives you a message. This is an example of destination port 67. It shows you that it has been hit. So this is logging. Now it doesn't create a syslog for every single hit. Once you've got one or two, it'll then start counting them, and it'll show you hits 20, for example, or hits 40, so that it doesn't use up too much resource. Enforcement counters. Now, I think we're all probably familiar that you can see these role-based counters within our network devices. It shows CTS role-based counters, and you can see here a number of hit counts from source to destination SGTs. That's what those hit counts are. Now, fairly recently, we've been able to retrieve these hit counts into Cisco DNA Center. And if you see this little switch on the top right here, if you press the left-hand icon, then you see the matrix, which is what you normally see by default. But if you click on the list view, you see the policies in list view, and you see permits and denies. So these are hit counts retrieved from the network devices. And also on the overview tab here, this is a little bit small, but the overview tab, you have most active policies and least active policies, and these are those hit counts retrieved as well. So again, this is telemetry, which is received from the network devices, and that telemetry is received every 15 minutes up to Cisco DNA Center. And lastly, just wanted to update you on a document that has been written on the 9800. So this wasn't really documented that well in the past and fully tested solution-wise. So we took the 9800, we created high availability instances, we created a guest anchor, we had APs with local mode, so that's central switching, and also flex mode, so we took all these modes, we tested all the SGT operations, that is the propagation with SXP inline tagging, the CTS provisioning and enrollment, the change of authorization, east-west enforcement, north-south enforcing, the monitor mode, high availability, the foreign anchor, logging, net flow, so all that information is within the doc. So there's the link. So it's everything that I could think of for SGTs and group-based policy in the 9800, and of course this is controlled by ISE. So this is the policy download functions onto the 9800. So I hope that's of use. And then there's just some ISE resources here. When Rigo posts these slides, you could have a look at these resources of different ISE guides, and also group-based policy guides. Now, this is a white paper. The first one is a white paper I've written on segmentation strategy using SGTs, and also my troubleshooting guide to help you along your way. And there's also YouTube and community resources to help you with your SGT journey.